Hello and welcome. Today we're continuing with our discussion on the preparation of alkenes, and as we mentioned before, alkenes contain carbon-carbon double bond. And this is still part of organic chemistry. Now last time we looked at dehydration, and you can look for my video. I will include the link below this video in the description section, where dehydrohalogenation was carried out, which is also a form of elimination reaction. In this video, we are looking at dehydration, which is also an elimination reaction. Dehydration means you lose water, so H2O. Now, this reaction requires alcohols as substrates, and alcohols contain carbon OH functional group. So when you're looking at dehydration, we are going to lose that OH plus a hydrogen on the next carbon, and here we have carbon labeled A, and it has two hydrogens. So if you lose one hydrogen, say this hydrogen, you end up with a double bond in this position. So you end up with the product having a double bond there. The other option is losing hydrogen at carbon labeled B. So this carbon here. When you lose that hydrogen together with the OH, now you end up with a double bond at this position. And then the last product will be the loss of one of these hydrogens at carbon labeled C, which has three hydrogens. So when you lose this hydrogen, for example, together with the OH, you end up with a double bond here. So we see that we have three possible products. Using Zaitsev's rule, which states that the favored product, that's the major product, is the most substituted alkene. That means the alkene that has the highest number of alkyl groups around the double bond. So if we look at the first product here, we see that the double bond is right there. Then we count the number of alkyl groups around the double bond, and they are 1, 2, and 3. So that's a tri-substituted alkene. And if you look at this alkene double bond, the number of R groups or alkyl groups is 1 and 2. There's nothing on these two positions. So that will be a di-substituted alkene. And then if we look at this other alkene product and focus on the double bond, it has 1, 2, and 3. And that also makes it a tri-substituted alkene. So according to Zaitsev's rule, the most substituted alkene will be favored, and that will mean that this tri and the other tri-substituted alkene will be favored, while the di-substituted alkene will be less favored. And actually the order of stability is you start with tetra-substituted, which has 4 groups around the double bond, 1, 2, 3, and 4. And then that's more stable than tri-substituted, 1, 2, and 3, which is more stable than di-substituted. Now the most stable di-substituted is transalkene, where you have the 1 and 2 groups opposite each other, which is more stable than cis-alkene. And that's more stable than the alkene where you have both groups, 1 and 2, on the same carbon. And then of course, this di-substituted alkene is more stable than monosubstituted alkene, which is more stable than just alkene with no alkyl groups. Thank you very much for your time. Please support the channel by subscribing and also by commenting. On the next video, we're going to look at preparations of alkenes using Vedic olefination.